Hi. Last video learned about the availability zones and the regions. Okay. Now our aim in this video is to establish a connection to a VM uh, by creating a VPC subnet uh, and connect and making a route through that VPC and subnet. So before doing that, this is my AWS console. So you can create an account by signing here. Just I don't want to show it. It is small thing. So let's log into the console. Okay. So let's give my email ID. See. Okay. Right. This is multi-factor authentication. Uh, but just to know, multi-factor authentication is the most commonly used way to log in organizations. So whenever you join any organization, you will get an account. Um, you will get access to the AWS account, AWS console account with the multi-factor authentication. So they might be using some Google Authenticator or their own custom authenticator, third parties authenticators. So that MFA we can configure in our AWS. So our account will be secured. That's So now when we log into our console, we can clearly see here the regions. So how many regions we have in AWS? So there are so many regions. So we talked about Mumbai region and North Virginia. So we have different regions there. So you can change the region from here. So I can go to North Virginia region, right? So now I am up on North Virginia region. So whatever the resources I create, they will be created on North Virginia regions. When I say resources in AWS, everything we create is a resource. Just remember that. So whatever we are creating in AWS is called a resource. So let's go back to Mumbai. Mumbai. Yeah, this is Mumbai. So here we need to create a VPC first. So before going to VPC, we can talk about IPs. So generally we have IPs, public and private IPs. So what are public IPs? Public IP. So it is used for internet connection, like which are accessible um, for the outside world. So outside world, like these IPs are assigned to the applications for applications. So that uh, they can assign these IPs to the DNS names. Like, so if you have a like facebook.com, they will be having a public number of public IPs. So um, they will link this public IP to their DNS name, like facebook.com, uh, twitter.com, so like that. So public IPs are which are available, which are accessible for the outside world, uh, and another one is private IPs. Private IPs are like were used in the organizations to assign the VMs their own IPs uh, to establish the connections. So those are the differences. Uh, so here public IP means we need to buy this IP. Uh, so we need to buy an IP. Uh, so and assign the type to our application. So I mean application in the sense we will give it to DNS name, uh, and the public IP is to build our infrastructure using private IPs. So these public IP can be accessible via internet, and this private IP cannot be accessible uh, from the internet unless it is open through a public IP again. So private IP we will generally use in organizations. We connect to different servers using PuTTY, and for all internal communication we use a private IP in a particular organization. So that is the main difference. So in private IPs we have three uh, three classes. So class A, class B, and class C. So class A, class B, and class C. So class A, B, and C. So in class A, it generally start with 10.0.0.0. This one must be 172, I guess, 172.16.0.0. Next, this one 192.168.0.0, right? So uh, class A, class B, and class C. So we will segregate our network into different subnets, each subnet having a different IP range. So because in each subnet we need to launch virtual machines at the end of the day. Each virtual machine is having an IP. So the subnet should have like if we are designing, so our aim is to launch 100 machines, 100 virtual machines in our organization. So we can create a subnet that allows you to create 100 IPs. So similarly, so if you have 1,000 IPs, you need 10 subnets. So for example, the scenario is you need to create 10 subnets, each subnet consisting of 100 IP. So that should be established. So because that one we uh, so because of that, mm, because to achieve that kind of architecture, we will use these class A, class B, and class C IPs. So we will not go much into this IPs because I also don't know much about this IPs because these are networking things configured by. But you should know that minimum knowledge. So what is a public IP? What is a private IP? Why we are giving class A, class B, class C only? So we have class D and class E as well, but class D is reserved for multicast. That multicast communication, and class D is reserved for future use. So like similarly we have to know what is the starting IP. What is the starting IP? Starting IP is 0.0.0.0, which represents all, which represents internet, all users. Mm, so which all users, which represents a publicly accessible IP. uh, so and all users, and one last one, 255.255.255. this represents all hosts. So this represents all users and this represents all hosts. So whenever you are allowing, whenever you give a rule to allow from all these IPs, that means you are allowing all the public users into your network. So whenever you are, let's say whenever you are you give a ping to this particular IP, that means you are trying to ping all the machines in your network. So that kind of so for creating a VPC, we need to select which class of IP address we are going to use. So whether we are using class A, class C. So class A, so the easiest way to do this uh, segregation of IPs is to use a tool. So you may be good at maths, you can calculate, but I am not good. So I am using an online calculator. Let's say online subnet calculator. Okay, so this one. Let's say I will just think of uh, like this. So let's say I am creating a VPC. Okay, let's say this is my VPC. And let's say I created two subnets in it, right? Okay, okay, and then subnet one, subnet two. So okay, so this particular VPC determines what class of IP we are going to use. So let's say I am using class A. Here I am using class A IP address 10.0.0.0. So you should be um, manually selecting the IP. So you should select the manual. You should select this private IP class manually to the VPC first. So you should know what class we are going to use to that VPC. So once you know that, so you should be understanding, okay, I have to launch two subnets in our VPC. So how many machines we need in each subnet? So that is a task here. So you don't have to know all the I mean, you don't have to be perfect in this IP knowledge, because your network team will help you. Uh, but you have to know how many hosts you need in each subnet, so that you can able to segregate your particular IP class to different ranges. So for suppose I need here for suppose I need here 100 machines, 100 VMs I need in this subnet, and here I need 100 VMs, right? So I need 100 VMs here and 100 VMs here. uh, so so we need to know we know the IP I mean class which we are going to use, and we also know how many subnets we have to launch in that network, and we know how many VMs we need to create in those subnets. Sometimes it may vary. So sometimes this subnet only need 100, this subnet need 1000. So it may vary. So for this, so let's say I have to create 100 subnets here. So let's go to the subnet calculator. Let's see how to use it. Okay, so here is my subnet calculator. I know what network class I going to use. I'm going to use class A network, and how many hosts, how many VMs we need, how many VMs. So here thing is here we where is it? So here we are saying 100 VMs. That means each VM has one IP. So we have to create in such a way that, so 100, how many IPs we need? So some VMs may need um, two IPs. So I mean two network cards we can attach to one one VM, but it all depends upon our architecture. So generally what happens is we will reserve more number of IPs for the future use, so that there will be never there will be no scarcity in future. So let's say here I need to launch only um, like only 50 only 10 applications. I need to launch only 10 applications. Even though I need to launch only 10 applications with 10 servers, I will give an capacity of 100 just to be sure that sure for the future use, right? Okay. So assume we need 100 hosts here. I mean 100 IPs. Uh, let's say, so here we can select host per subnet. So how many hosts per subnet? Each host will take one IP. So how many hosts we need? 100 hosts. So here we can see we cannot precisely give the number. There is some calculation, so based upon that calculation we will select. So we cannot give 100 correct 100 exact 100, but we can give 126. So I will select 126 because it is higher than 100. So our aim is achieved there. So our ultimate aim is to give the subnet 100 IPs. So I given 100 IPs. So here my IP range is this one, and my network mask bits are 25. So sorry, I changed it. Okay, 126 IPs, my mask bits is 25, right? Yes. So mask bits is something. So if you change the mask bits, for suppose the maximum mask bits we can give to any class is 16. Either it is class you are choosing class A, class B, or class C. The maximum number of subnet. Sorry, the maximum the maximum mass bits we can give is 16. Why 16 is a low number, but it gives the maximum. So the minimum we can give is 28. We cannot give 29, 28. So which gives 14 IPs to that particular subnet, right? So for suppose we say we selected our class A and with 16-bit mask, and we will get 65,524 IPs in each subnet. And how many subnets we're gonna create? We can create 256 subnets. So anyway, so when select this one, I mean we don't want 256 IPs, even though we can give the maximum bits for because there is no harm in giving the maximum number of IPs, because we can use it in future if needed. So that is small introduction I can do on subnets. On the IPs. So we need to give a 100 IPs here. So what I can do? So 10.0.0, let's say 1.0 slash my mask width is 25, right? So similarly here also 100. So I can give 10.0.2.0. So and 25. So let's see how can we create this particular network in AWS. Sorry, not this one. This one, right? So first we need to create a VPC. I'm gonna go to VPCs, right? Create VPC. You can give any name. It should be unique. But anyway, each, as I said, even though the name is same, sometimes you may create VPCs with same name, but the ID, VPC ID which is generated will be different. Let's say this. Let's say this is a dev environment, dev VPC, dev VPC. My name. And what is the CIDR class? This is the class which we're gonna select. So this is the main class, like what I said. This is the class we need to decide here. So on the top of subnets. So here we can select 10.0.0.0 slash. As I said, we can take the maximum mask bits so that we can segregate in subnets. So if we take 25 here, so okay, so let's assume we take only 25 here. So what are the number of IPs we are gonna get when we use the mask bit 25 is 100. So your VPC is getting only 100 IPs. Okay, so when you are creating a subnets, if you need subnets like more than you need the machines which if the machine count is more than 100, you cannot assign IPs for that subnets, because there is no IPs for your VPC. So you have to give maximum IPs to your VPC, and you can divide that IPs into different subnets later on. So if you give like 100 IPs, 200 IPs to your VPC, then you will be getting a scarcity to in future. For suppose you have a like so assume your network, your subnets here you have two subnets. You given 100 for each subnet, and you took only 200 here. Okay, uh, 200 subnets for your VPC. Uh, what happen is in future, if you want to add 10 more machines in this VPC, or if you want to launch another subnet and you want to add 10 machines to that subnet, there is no IPs available to give to that subnet, right? So that is why we select maximum subnets to VPC whenever we are creating a VPC, and we can then segregate our, we can divide our IPs into parts using subnets. So each subnet, as I said, you can give 100, you can give 1000. It may differ, but ultimately you cannot exceed the IPs which you give into VPC. That is the concept here. So that is why instead of taking 25, 24, 28, so I'm taking 16. So this is the maximum subnet mask um, that can get a high number of IPs to our VPC. So if I give 16, it will get the maximum IPs in this class, right? What are the maximum IPs in this class? It is around 65,500 something. So those many IPs I can get to my VPC. Then once I get that 65,000 IPs, I can then segregate those IPs into different subnets depending upon my requirement. Okay, so IPv6, we are not using IPv6 in present time, because IPv6 is more advanced and it has more difficulties in configuration. So none of the organizations, very few organizations, they are using IPv6 as far as I know. So this tenancy is default as of now. Um, so we are not using a dedicated tenancy um, uh, because we are not choosing we are not choosing our own data center, right? If you have reserved instances, for suppose uh, mm, uh, what how can I say this? Mm, so this tenancy is like all the resources we create are within this dedicated VPC. So I cannot explain this one. No, tenancy is specific to this VPC. So whenever we are using the dedicated tenancy, uh, we cannot no, we can discuss this later. I am also not sure about how this gonna differ. Generally, it is a dedicated host. I mean, whenever creating the resources, it will segregate from resources from our VPC, uh, like that. So and big so one of the questions we get is whether we can change our VPC name after after creation of VPC. So generally we will not be able to change our VPC um, name. So or we cannot change our VPC CIDR block. So we can change it, but there are ways. But uh, generally we will not use it. It is very difficult. Okay. You will get an option. I will show that option where you can change, but I never changed it. So let's say create VPC. What we have? So my VPC is created. So let's go to your VPC. So this is my dev VPC. Okay. So I just scroll down. You'll get the VPC ID and few details of your VPC. CIDR block which you given, right? This is how we create a VPC. This is CIDR block, right? You go to actions. You can also delete this VPC. We can do it later. I was searching DNS resolution. Edit CRDR. Yeah, this is what I am talking about. So if you given a CRDR block which is having a less IPs, for suppose you can say 25 here in the subnet mask. So add you can then add a VPC ID. You can add to this particular VPC. You can add a secondary IP address, but that make our network complicated. So that we should avoid while creating an architecture. Just to make it simple, it should be a it should not be complicated. So that's why we will take maximum number of IPs generally. Okay, that's it. We created a VPC. Uh, Now, what happens? So we created a VPC. Good. We should create a subnets and uh, assign IPs to that subnet. So how we do that? I will create a subnet now. Go to subnets. So how these options? How you can get these options? You can go to services at the top. Okay. You can go to um, networking. Where is my networking? You can see networking and content delivery VPC. And so this is our this is where we are doing these changes. Okay, so if you go to VPC, then we'll get these options. So now we have to go to subnets, create a subnet, right? Create a subnet. So in which VPC we are going to create this subnet? So what is our VPC name? Dev VPC. You can see each VPC is having a different ID, VPC ID. So we'll select the VPC. So this is the VPC CIDR block. It is named. Okay. Subnet name. You can mention subnet 1. Preferred availability zones. So as I said, our VPC is will be spread over different availability. So how they are spreading over different availability zones? Um, uh, they are spreading through subnets. So if I create this subnet in 1A, so I'm creating this VPC in only one subnet, right? So that means we can discuss this later. One second. We can discuss. Sure. Yeah, not this one. This one, I guess. Yes. So here we are creating our VPC in only this particular region, 1A. Okay, using a one subnet. So when I configure the next subnet, I will choose 1B subnet. So it will extend the VPC to other subnet. So this is how this virtual VPC is extended to all available regions, right? Okay. So once we select the availability zone, we have to select CIDR block for our subnet. As I said, you need only 100 IPs in your subnet. You can go for 10.0.1.0 slash, right, sorry, 10.0.0.1.0 slash 24. Okay, so I selected the CIDR block. So whenever you select 24, let's check how many IPs we can get in the subnet. So I select how many I selected 24. Okay, so I selected 24 in each subnet. I can get 254 IPs. So how many subnets I get? I get 65,536 subnets I can get. Each subnet can take 254 IPs, right? So that is how we create it. Okay, then create. Right, we created a subnet. We can go create another subnet. Here we are filtering with subnet. We go to subnets again. We can remove the filter twice. So it will show all the. I already have some subnets. I ignore them. Like we created subnet one, create another subnet, and the subnet we create in the same VPC. That is what I mean. So we need to select the same VPC and we select subnet 2 availability zone. Now instead of selecting 1A again, we will select 1B so that our VPC will extend to another availability zone, right? So that is what I mean in this diagram. So we created one subnet in this one, another subnet in this one, so that our VPC will extend to both the availabilities, right? So if you select, if you create another subnet, you select 1C, our VPC will extend to further to this availability, right? Now 10.0.2.0 slash 20. We can select 25. It will give 100 IPs. Before we selected 24, it will get 254 IPs. Now I need only 100 IPs in this server, in this subnet. So I will select only 25 and create subnet. I created two subnets. Right. This is how we create VPC and subnets. So our final aim, just a reminder, we need to launch a VM in these subnets and we have to connect through PuTTY. That is our aim. So here the aim, here we can directly create a EC2 instance in the default subnet which Amazon is providing. So by default, when you open an Amazon account, AWS account, I mean, so they will give a default VPC and they will give a default settings for everything. And you can just launch an EC2 instance, it will directly created in the default VPC. And if you directly, if you open port 22, you can directly connect from PuTTY. But here we are not, we don't want to do that. We do this lab in the default VPC where everything is set up. So we have to do this from the scratch. So what we are, sorry, Okay, so what we are establishing here, so we created a VPC, and we created two subnets, right? This is subnet 1 and this is subnet 2. Subnet 1, 8. So we created this infrastructure. But whenever you are connecting from putty, this is, assume this is my putty. So if it is your own organization, so where in your network you can directly connect to your instances, right? But whenever you are connecting from internet, so here we are connecting from internet, via internet, I can say. So this is my internet. So we are connecting to AWS via internet. So there is no VPN connection here. So there is no network, what do you say, um, direct network connect or direct connect here. So we are connecting through internet. So how you can, so here how VPC, by default VPC will not take any anything, any request coming from the internet, right? No, it will not take, because there is no ports open, nothing is configured here. So how VPC will connect to internet? That is what we need to know here. So the VPC will connect to the internet via internet gateway, right? So this is my internet gateway, right? So this we need to create and attach to our internet. So okay, uh, this is IGW. So this is our internet gateway. So through this internet gateway, the VPC will get request from the internet, whether it is a our request, like uh, the admins used to connect, or the applications will also open through internet gateway. So even the applications will get the request through internet gateway only. So if there is no internet gateway, your network is not connected to internet, and your application will not get any request from the internet. So, right, right. So we can just, this is to and fro. Anyway, right. This is to and fro. So the request will come here and will go from the same path. So internet gateway. So next thing is to connect internet gateway to VPC. So even though once we connect to the internet gateway to VPC, uh, the request will stop at VPC level. So request will know which VPC to, it will come through internet gateway and it will connect to VPC. So after connecting to VPC, the request don't know where, um, don't know which subnet which subnet to connect or which resource to connect, right? So now again we have to create a route table here. So route in the sense the way of the path where the request can flow. So here we can create a route table here. Here we can create a route table, and through that route node, this is my route table. Let's say the route table, right? So I will create a route table. I will add some routes. ROUT, route 1, route 2. So how many we can add n number of routes? Not n number of routes really. It will support like 120 or 125 routes per each table, I guess. So create a route table Okay, so for the request to know just which subnets to connect, right? Once we clear route table and we allow the route, so it will be able to communicate with the resources inside the subnet, right? So this is what we need to do now. So we can do it in the next video.